This is a demonstration of an early style flyback transformer. I'm using the original primary winding. As you can see, there's no added on primary coil. So that primary winding has a lot of inductance since it was designed to be used with the high voltage from a vacuum tube. So because of that, I couldn't run it in a resonant mode. It wouldn't respond very well. As you can see, there's no capacitor added on to it. So this is run straight as it was back in its day. This early design also has a lot to be desired. As you can see, it has a very long magnetic path, which tends to be lossy. And you'll also notice that the secondary winding is not coupled very tightly to those magnetics. So we're not going to get a real lot of power out of this in comparison to the newer designs. So we're going to run a demonstration on this just to see what it was like. Also on this design, the core gap is very crucial. Without it, you really can't drive it with very high voltage. You'd run into spurious resonances and all kind of stuff. So I'm using 3 layers of masking tape on the core gap. So I'm driving this transformer with 2 compactron vacuum tubes in parallel, and I have a variable frequency driver, and I can adjust the duty cycle so we can tune this to its peak frequency. Okay, we're on operation right now. 200 volts input, a little over 100 milliamps. We'll crank it up. That's like 350 volts on the input. We're looking at like 80 watts, maybe 100 peak. I'll adjust the frequency and watch what happens. Power supply. I'll crank the voltage down. Really runs the nicest at like a little over 200 volts. Crank it down. Just a quick look at our driver circuit. These are 2 6LF6 compactrons. There's our driver. We have a filament transformer, and that transformer also powers our circuitry. Transformer here supplies the high voltage DC to power an IGBT, which then controls the grid through RC coupling. I'm using a 555 timer chip with a LM319 to adjust the duty cycle, and I'm just using a IGBT driver chip to drive an IGBT. So there's a little over 100 volts on the grid signal. And we'll hook a oscilloscope up to it, and so here is one quick look at our waveform on the grid. I will adjust the frequency. And duty cycle. I have now added a rectifier to this, and we'll make some arcs with it and see how it looks. Maximum voltage occurs around just under 200 volts on the input. Bring it up, 300. It falls off at the higher frequency.